dear students, I'm Meghamala, working as assistant professor from Electronics and Communication Department, Institute of Aeronautical Engineering. And today, I'm going to talk about the problem solving on behavioral modeling. So far we have discussed few problems on Verilog as in HTL, and then today we will discuss some more problems, okay, and how to solve the problems in terms of behavioral modeling. So before we go into the problematic statements, let us discuss something about the tasks and the functions in the behavioral modeling. So coming to the tasks, okay, so coming to the tasks are declared within a module. So within a module, these tasks, okay, whatever the task we are supposed to have it, so we will be the mention or else the declaration of this task will be declared within a module, and they may be referenced only from within a cycle or single pass behavior. So here we are saying that tasks are meant something where we need to declare only within a module, okay, only within a module, and also they are referenced, okay, they may be referenced only from within a cycle or single pass behavior. And then a task can have parameters. So likewise, different sections, like we have different modules, we have different parameters to be discussed, right? So in the same fashion, for this task we have a parameters which are passed to it, and the result of executing the task can passed back to the environment. So here the task also do have the parameters in the Verilog. So and when a task is called, copies of the parameters in the environment are associated with the inputs, outputs and inouts within the task according to the order in which the input, outputs and inouts are declared. So here we are saying that tasks are called, okay, when a task is called, what happens is when a task is called is the copies of parameters. So whatever the parameters we are having in such a particular circuit diagram, or is in a particular circuit, whatever the parameters that we are considering, okay, they are copied. Okay, when the task is supposed to be called, the parameters which are pertaining to that particular module, they are called in the environment, and they are associated with the input, output and the in-out ports, whatever we are considering as per the circuit. Okay, then a task must be named. Okay, so for example, if you are considering some task, if you are performing some task, then you have to give the name to that particular task. So they must be named and may include declarations of any number or combination of the following patterns. So you have to give the name to that particular task, and after giving the name, you have to declare. Okay, they have we must declare the declaration of the parameters should be constrained with respect to the number and also the combination of the parameters. So the combination and as well as the name that we are giving to that particular task, they must contain the parameters and also inputs, outputs, in-out, register, integer, real time and as event, right? So remember, task is nothing but it is declared within the module, and also we are saying that they are referenced only in the form of a cycle, and the task, they do have some parameters. The parameters are in terms of input, output and as well as the in-out, right? Then the variables types are real time and real time are additional members of the registers family types. So here we know few parameters, right? So as we have declared here, few parameters are in terms of input, output, in-out, register, integer, real and the real time and also the event. Okay, so we are saying that we have the families of such parameters, whatever we are considering respective of the task that you are performing. Then functions in Verilog. Coming to the functions, so what are the different functions that we can see in the Verilog? So the function that does not consume simulation time. Okay, we know that the functions they don't consume any simulation time, and returns a single value of an expression. So it will have, in the expression, it will have only a single value. Okay, it will have single value, and the functions will they does not consume. See, the function does not consume any time. Okay, the time constraint is not considered in the functions, but it returns a single value with an expression, or may or may not task. Okay, so what sort of keywords that we can use in the function is, function and end function. We all know that the keywords we use like module and end module, right? Generate and end generate. Likewise, in the functions, we are using the syntax in terms of functions and as well as the end functions. So these are the keywords which we are supposed to write, or else which we are supposed to declare when you are writing a proper code in terms of function, right? So now the syntax goes like this: style 1, function, written type, function name. And see, this is a port list. In the port list, we are mentioning input, output, port list, in-out port list as well, right? Then return value expression. As I said you, in the functions, it returns a single value or an expression. So here we are declaring return value of the expression. And then finally, end function. We started with the function and we are supposed to end with the end function. This is one style of writing a syntax of functions. Then coming to the style 2. In the style 2, the function is a keyword mentioned. Along with the function keyword, we are mentioning the return type, right? Return type and as well as the function name, the name of the function. And then goes as per the inputs and also the outputs. Input port list, output port list, and output port list as well. Separately, we are mentioning, or else the declaration of input, output, and in output are declared separately. And then finally, written value or expression, and then goes with the end function. So these are the two styles of writing a syntax or else a code in terms of considering the functions in the Verilog. Then now we will see the example. In the example, if you observe, module, keyword, function, example. So function compare input A and B, and I'm considering the if case, right? So if A greater than B, what is that? I have to if A greater than B, it says that A is greater than B. This is what in the display we will get. Then if A less than B, and then we will get A is less than B. And if A is equals to B, A is equals to B. Okay, then written 1. In the written 1, not mandatory to write. So here in the returns, there is no need to there is no mandatory to write there is no mandatory, or else it's not compulsory to write the statement or else a comment, okay, pertaining to that. Then end function. Then what am I doing is initial begin. Now I'm comparing A greater than B, A less than B, and A equals to B. This is what I am comparing, right? Then after that, N, and then goes with the end module. So this is the example that I have considered, and the example, the output, what I will get is A is equals to B, A less than B, and A greater than B. Okay, this is some function, right? This example is talking all about the function, the syntax of how we write the function using the keyword function and the end function. Okay, so just by comparing the two elements A and B, just by comparing the two things, how are we writing the function in the syntax code or else in the code format? This is what the explanation is. Okay, then we'll move forward. Now coming to the task in Verilog. In the Verilog, we already discussed the task, right? So using task, how can we write the code? This is what we see now. A task that may or may not consume simulation time, returns value as output or input in out argument type, and may or may not take argument. So here, remember that it's almost like a function, but here the thing that you have to ponder is, see, it may not consume simulation time. Okay, there's no need to consider the simulation time. Return values as output or in-out argument type. So the return type values, they may be in terms of output or in terms of in-out argument, right? Then we see here we are not saying anywhere input. Okay, only output, in-out. Then the keywords that we are using in terms of task is task and as well as the end task, right? So here also in task, we are considering two formats, two styles to write the code. So style 1 goes like this: task, name of the task, and this is a port list. right? So in the port list, what are we supposed to write? In the port list, we have to write only input port list, in-out port list, and as well as the output port list, right? Then finally some statements pertaining to the condition that you are considering, and then end task. So this is one form of writing a code. And then the second form is style to task name, input port, output port. Clearly we are mentioning here. What we're doing is, in the port list, we are all together in the port list, we are mentioning by using comma, right? Input, output, and in-out. But whereas in style 2, how are we writing is, separately we are indicating input, output, and as well as the in-output. And finally, after the statements, we are ending the task. So end task. So this is a few differences. Almost task and functions are they both are similar, but the few differences that you can find out if you compare task and functions. Mainly, if you are writing the code in terms of task, remember that your code should start with task and end with end task, right? If you are writing your code in terms of function, then your keyword must start with the function and then end function. Okay, and now we will see. So this is a small example based on the task. Module task example, and now here we are comparing the task, right? So input A and B and output done. So same, A greater than B, A less than B, and A equals to B. And now what are we doing is, here we are displaying some delays. So 10 nanoseconds of delay. That means what? At 10 nanoseconds of delay, I'm going to observe A is greater than B. After 10 nanoseconds of delay, I'm coming to the confirmation that A is equals to B. And at 10 nanoseconds of delay, I'm coming to the conclusion that A is less than B. And then finally, end task, right? Then initial begin. So bitwise bit I'm considering. So bit done. And now I'm compare 10, 10 and done. And now if it is done, now I have to say that the comparison completed at time 0 t, right? And then 5, 9. See, 10, 10, it means like A is equals to B. And if it is 5, 9, A is less than B. And here it is 9, 5. So here A is greater than B. And then finally end module. Okay. So this example is in terms of task. And then finally output, I can get that. Simply A is equals to B, comparison at the completed at time 10 nanoseconds, and B is about 20 nanoseconds. And that means A is equals to B is at 10 nanoseconds, 10 nanoseconds of delay, and A is less than B is all about 20 nanoseconds of delay, and A is greater than B at 30 nanoseconds of delay, right? So this is the output that we are going to observe if you are writing your code in terms of task. And previously we have discussed, if you are writing your code in terms of functions, then this is how the two kinds of different variations you can write your code, and this is how the output is being observed, right? So till now we have discussed about task and functions, and let's move forward. And now we will see the difference between functions and task. So what are the functions and task? Function is nothing but the functions cannot contain simulation delay. So here we are saying that the functions and task even we are not considering, or else they don't consider in terms of the timing constraint, right? So here it is mentioned where they may not consume simulation time. So here simulation time they may not consider. So when they are not considering the simulation time, obviously the function, they cannot contain the simulation delay. When there is no simulation time, no simulation delay is to be considered then. So execute in the same time unit, and it cannot contain at the rate, wait, negative age and positive age time control statement. So here remember that functions in the code, the functions, nowhere you will see it's not at all related with in terms of the simulation delay, and as well it cannot contain, okay, it cannot contain at the rate, and it cannot contain wait statements, okay, and it cannot contain the positive edge and the negative edge memory elements, right? You will see all these things in the memory element. So it may not contain the positive edge and negative edge, and also the time control statement. Time control statements always depends upon the curve that you are considering. If you are taking from 0 to 1, then it is a positive edge. If you're considering from 1 to 0, then it is a negative edge. Always it's a time control statement. The functions are. Then the functions can return a single value. So the return value of the functions is obviously a single value. And then they cannot call another task. So when one function is in the process, the other functions cannot come and interrupt the present one. Okay, unless and until the first process is done, the next task will come into the existence. So it's like a sequence manner. The first one will come. It just implements its task, and then it takes over its time as per the time given, and then it terminates. And then the next task will come, and so it will do all this, all the priorities, and then it will end up. So it is like a sequence manner, but in the interruptions cannot be seen in the functions. And now we will look into the task. So task is nothing but task can or cannot contain a simulation time delay. Okay, so here also, like functions, task may or may not contain the delay, right? And also they may not contain the always, and they may not contain the wait. Same like the task, like functions, negative edge, positive edge, time control statements. Okay, then the task can return multiple values as output or in out argument, right? So what did we observe in functions? We observed in functions saying that they return only single value. The functions will return only single value. But whereas the task, it can return the multiple values, right? So this is the difference that you can understand between the task and the functions. The functions goes only with the written value, but whereas the task goes with the multiple values. So multiple values it can go with, or else the output, like multiple values in terms of output, or else in terms of in-out argument, right? And then it cannot return a value that a function can do. So here the task has to perform the task given to it, but it cannot return to a value that a function can do. So whatever the function is doing its work, the task cannot imitate the function. Okay, the task is different and the function is different. If the task has to do something, it has to do in its own way, but it cannot imitate the function. It cannot imitate like function. So that's what it's saying. The value that a function can do, the task cannot imitate the value that a function can do, right? Then the task can call another function or task. So here in the function we are saying that the function cannot call another task in between when the process are occurring. That means when the tasks are implementing in a sequence manner, we are saying that the interruptions cannot occur. The interruptions occurring is not seen in the functions, but whereas in the task we are saying that the task can call another function or task when the T1 is processing. Okay, when the T1 is processing, after the terminating of T1, automatically the T2 will come into existence, right? So, but here in the task, we are saying that when the T1 is in the process, then the next moment when it is in the process, there is an access of getting another task T2, right? Unless it doesn't bother whether it is ended or else whether it is terminated or not. But the second thing, once T1 has entered into the process, the T2 will also, the T2 is getting ready, and the moment it's about to end it up, the task 2 will continue. Okay, the task 2 will come into existence. That's what we are saying, that the task can call another function or task. That means what here we are seeing the interruptions in the task. Then now we see the enabling, task enabling and the argument passing. So what is this task enabling? Is the statements that enables a task passes input output arguments, right? So here in the task we observe that the written values can be in terms of output, the written values are in terms of output, and also in terms of in-out arguments, right? So the statements enables a task with respect to in-out arguments, like how, comma, one, and the separated list of expressions. Okay, one thing is comma. Okay, the comma is mandatory. That means if you are considering more than 2 parameters, how can you consider A and B, right? So the comma and the separated list of expressions enclosed in the parenthesis. So separated list, see this is a parenthesis. So separated list of list of expressions are enclosed in the parenthesis. And also we are saying that this is a formal syntax in terms of the enabling, task enabling. So formal syntax goes like this: task enable. We are enabling the task, and then we are giving the name to that particular task. So the name of a task and then name of a task followed with the expressions, right? And then the first form of task enabling statement, it applies when there are no in-out arguments declared in the task body. So we see that the enabling statement, see these are the enabling statements. Expressions are nothing but the statements. So these are the enabling statements. We will apply these enabling statements where there are no input-output arguments declared in the task body. In the task body, that means what? From the task and the end task, there is no way of declaring the input-output arguments, right? That is what the sentence talks about. Then, in the second form, so in the first form, we are saying that there is no input-output argument that is declared in the body, task body. That is the first thing. The second thing goes, the list of expressions. Okay, the list of expressions is an ordered list, and that must match the order of the list of input-output argument in the task definition. So in the task definition, the second step is all about the expression, the list of expression items. The expression items, it must match the order of input-output arguments. So it must match certain order. Okay, so certain order with respect to the input-output arguments in the task definition, it must match it. Okay, it must match with respect to the list of the expressions. This is the two forms of task enabling to write a proper code. And then we'll move forward. If an input-output argument is an input, for suppose IO argument is an input, then the corresponding expressions can be any expression. So if IO argument is input, so the output expression, so this kind of expression could be any expression when IO argument is about the input. And if suppose IO argument is output or in-out, so in the task and function, remember that we have three things in the port list: output, input and in-out, right? So the in-out arguments can be considered with respect to any sort of expressions if and only if the IO argument is in the input. And then if IO argument is in the output or in-out in the Verilog, it restricts into an expression that is valid to the left hand side of a procedural assignment. So onto the left hand side, this is the left hand side of a procedural assignment. This is the right hand side. In the right hand side, we will see the expressions. Onto the left hand side, we'll write the variables, right? We'll declare the variables. So what this sentence is talking about, if the in-out argument or the output argument, the Verilog restrict it to the expression. Okay, it will have some restrictions. Whereas in-out argument is going as per the output, as per the input. We see that in the expression, there is no change. Okay, we don't see any sort of change in the expressions if it is going as per the input. But if it is going as per the output, then we will see some restrictions to be valid, that is considered on to the left hand side of the procedural assignment. So this part we will see some restrictions. So the restrictions must be in terms of parameters. The restrictions must be in terms of the connecting devices that you are considering, and the restrictions will be in terms of the values that you are considering. Okay, so this is what the difference. Then now we will see these are the register, integer, real and time variable, memory interfaces, concatenation. We see these are nothing but the data types, right? So these are the data types, these are the memory references, and we see the concatenation of all the data types as well. And then with the concatenation of the memory references and bit select and part select of register. We know the bit select and part. So if this is a register, the bit select is nothing but this. This is a bit select. And if it is a part select, I divided this register into A and B. So if I'm considering part select, then I have to go to part A, right? So this is a part select. And then this is a small syntax goes with this module, this task, input declaration, output declaration, output as declared as D and E, and then register 1, 2, 3, and now we are beginning with the statements. So this statement, it will perform the works of the task. So how it is performing the works, the output, as per the outputs are like C and D and E, right? So C is equals to 1, D is equals to 2, and that's how E is equals to becomes F is 3, right? So then finally ending end task and end module. So here how the segregation of all the numbers have been made between the different parameters. The basic structure of task definition with 5 arguments. So here are the 5 arguments A, B, C, D, E. So how are we dividing? A and B are at one input and C, D as a output, like that. Then the following syntax enables the task in the example. So here my task, these are nothing but the arguments A, B, C, D, E. So totally 5 arguments we have, and corresponds to IO arguments. So calling arguments are these are the calling arguments, and IO arguments are A, B, C, D, E, which are defined by the task. And now a task enabling time, the input in-out arguments A, B, C receives a value which is passing V, W and X. Obviously, see, we have A, B, C, D, E. So these are nothing but the IO arguments. And now we have the calling arguments. Calling arguments are V, W, X, Y and Z. So when you are calling A, B, C, then you have to call the calling arguments as V, W and X. V, W and X. That is what it's saying. And then now coming to the execution part, the execution of the task enabling call effectively causes the how A as V, B as W and C as X. Then as a part of processing the task definition form Y task must place the computed results into C, D and E, right? So here how am I doing? X as C, Y as D and Z as E, right? So here simply we are mapping, okay? We are mapping the IO arguments with respect to the calling arguments. So when you are mapping, you have to be very careful that are you mapping the proper arguments or not. Sometimes there is a chaos. We'll see some chaos. How is with respect to the mapping, instead of mapping A to V, there's a chance of mapping A to W. So which is absolutely wrong, right? So we have to be very keen enough when you are mapping the IO arguments with respect to the calling arguments. And so this is all about the problems. When you are when you have problems in terms of mapping arguments between the task and the functions, then you have to be very careful in writing your code as per the styles that are mentioned. Okay, so for each task and as well as the functions, there are different models of modeling the code in terms of style 1 or style 2. Okay, in terms of style 1 and style 2. The only difference that you can observe in style 1 and style 2 is in the style 1, we will see in the port list, we will mention everything, input, output and as well as the in-out. Whereas in style 2, what are we doing is, we are just declaring the module, the name of the keyword. Okay, we are just declaring the keyword, and then after declaring the keyword, next steps, okay, the following steps would be what are the inputs. Inputs and outputs are declared separately, and then finally ending up with a particular task. If you are going as per the task, your keywords must be task and end task. If you are going as per the functions, your keywords must be function and end function. So this is all about the task and functions and the problems how to solve in terms of behavioral modeling. I hope you all understood. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.